So yes, friends, I am Bhuvanesh Oza, coming back to you. We have completed the talk on protection of transmission lines using overcurrent and earth fault relays. The another way of protecting a line is by using distance relays. So now onwards, we will talk on how to protect a transmission line by using distance protective relays. It is a general practice to protect very long extra high voltage lines of 132 kV and onwards, that is 220 kV, 400 kV, 765 kV and so on by distance relays. 66 kV and 11 kV lines are usually radial feeders, and to provide distance protection for such lines is costly affair. The general principle of cost, that is, the cost of protection should not exceed 5 to 10% of cost of equipment to be protected, will not justify the protection of 66 or 11 kV lines by overcurrent, 66 and 11 kV lines by distance relays. So they are protected by overcurrent relays. All lines of 132 kV onwards are protected by distance relays, but they are yet protected by overcurrent relays also as a backup, not as a main. As a main, it's only distance protection that is used. So the obvious question, why distance protection? See, when one kind of protection is available, why another kind of protection is required? This another kind of protection is required because overcurrent relays have got some limitations. And that will go on coming. That will go on coming till the life of the planet Earth ends. One technology has limitations, therefore the another technology. Second technology has limitation, therefore the third technology. That will go on. And therefore the engineers are and will be continuously needed. Scientists will be continuously needed. The researchers will be continuously needed to search for new technology. And engineers will be continuously needed to apply that technology which is researched. But right now, let us concentrate on limitations of overcurrent relays. The one limitation of overcurrent relays is ZS by ZL ratio, as we have talked about. ZS is the impedance from source to source up to the relaying point, and ZL is the impedance from relaying point to fault. Now, if ZS by ZL ratio is high, if ZS by ZL ratio is high, we had talked that the current is equal to E upon ZS plus ZL. If ZS by ZL is high, you can ignore ZL with reference to ZL with reference to ZS, and therefore the current will be more or less equal to E upon ZS for two different locations of fault. So those two different locations cannot be rather, so to say, discriminated. You cannot discriminate between two locations because fault current is more or less same. Time of operation more or less same. So to discriminate between these two fault locations becomes difficult. Whereas if you go for distance protection, what does the distance protection do? Distance protection works on the principle that it measures the local voltage. Local voltage means if I have to protect the line from Ahmedabad to Baroda, I have to measure voltage at Ahmedabad bus and local current, that is Ahmedabad to Baroda line current, and find out the ratio of voltage to current, that is Z. What is that Z? Z is from Ahmedabad bus to fault. If that Z is less than some set impedance K, I would call it K. If that measured Z is less than K, that means the fault lies within the zone of protection. The relay will operate, otherwise the relay will block. Now, this local voltage has nothing to do with what is the source, because I am not measuring the source impedance. Therefore, it is practically not affected by ZS by ZL ratio. Second problem with the overcurrent relays is varying generating conditions. At night, the load is less, therefore the number of generators required are less. And when the number of generators are less, the fault current is less. So fault current at night time, that means fault current with minimum number of generators connected, will be less, and the fault current with maximum number of generators connected during daytime will be higher. And in the limiting case, it may so happen that the fault current with minimum generating conditions is lower than the load current with maximum generating condition. Usually fault current is high, but here fault current is less and load current is more. Load current with maximum generation. Maximum generation means maximum number of generators connected. So if fault current with minimum generation is less than load current with maximum generation, then it is difficult to set the overcurrent relay alone. You have to use the voltage controlled overcurrent relay, and so to say, principally voltage controlled overcurrent relay is the principle of distance protection. So we have come to distance protection in that case, the remedy. The third problem is overcurrent relays achieve selectivity by time grading. That is, the relay farthest from source, that is relay nearest to the load, is given the least time of operation, is set with the least time of operation, and as we go towards the source, we go on increasing the time by discrimination time margin 0.25 second. So when we reach to source, the time of operation may be 1 second or 1.5 seconds or something. It would be more. So the problem is the fault near the source, which is the worst fault, which is a reason for the worst damage to the equipment of power plant or power system, is cleared the latest. We are clearing that fault the latest. We should do reverse. The fault which is nearest to the source should be cleared the earliest. Fault near load can be cleared later because that fault current is low. But that we can't do based on selectivity of, principle of selectivity. Therefore, the major problem is time delay. Whereas distance protection does not achieve selectivity by time grading, it achieves selectivity by different principle. We are protecting the line section by 3 different zones, and therefore the problem is quite a lot solved when I go to the distance protection. The fourth problem, and probably the worst problem, is if we talk about the interconnected system. Say in one state, Gujarat, there are 100 transmission lines and 200 relays. And in that case, it is quite possible that one relay is backed up by some 11 or 12 relays. And then obviously the principle of selectivity says that relay 1 R1, which is backed up by 11 or 12 relays, out of which one relay, say R12, operates half 0.25 second later. Then in doing that, the another relay may have to operate very late. It has so often happened that for operation of the fastest relay to operate within just after 0.25 second, the another relay has to operate 11 seconds later. That has happened. The another problem is that in an interconnected system, for a particular fault, I mean that means the fault at a particular bus, neither the primary relay operates nor the secondary relay operates, and some third relay which is not connected at all and which is might be far will operate. And this is known as sympathy trip. And this sympathy trip does occur because today also people are doing research on optimization of relay setting, and while doing that research, one researcher says that in my algorithm the number of sympathy trips are 3. Then the another researcher says that it is 2. Then the another researcher is better because his sympathy trip are less. The third one may tell that it is only 1. And the fourth one may say that 1 also, the time taken between 2 relays, it is yet less. So it's like that. But sympathy trip does exist. Sympathy trip means mal-operation, fully mal-operation. That does happen. So that does not happen in case of distance protection, because distance protection is a protection in which, you see, it is seeing local voltage and local current only. So only the zone in which it should operate operates. Other things do not operate. So there is no question of sympathy trip, no question of mal-operation, right? So that is very important limitation and an important remedy. So that is for these reasons, for lines which are lying in an interconnected system, distance protection is used. The principle of distance relay. What is the principle of distance relay? That is what we would like to see. So to start with, I'll say that for very large generator, 210 megawatt, 500 megawatt, Xg, that is the inductive reactance. That also, it is in 3 parts. That is the subtransient reactance, transient reactance, and steady state reactance. But that steady state reactance may be as large as 50 times Rg, the resistance of the generator. Generator is highly reactive. Similarly, large transformer also, Xt is more or less equal to 50 times RT. Then coming to line. For 11 kV line, XL is equal to R, more or less. I'm not telling that it is exactly so. From design to design, it may be different, but in one design, XL may be equal to 0.9 R. In another design, XL may be equal to 1.1 R. But it is more or less in this range. For 66 kV lines, XL is equal to 3 times R. For 132 kV lines, roughly 5 times R. 220 kV lines, it is roughly 6 times R. And for 400 kV lines, XL is equal to 8 times R. If you do XL by R 8 and tan inverse XL by R, then that theta, phi, angle between current and voltage would be, I think, some 87, 88 degree or 91, 92 degree, right? So, when fault occurs, the angle between voltage and current is quite large, of the order of, if the fault is containing resistance, then it may be 70, 75 degree. And or otherwise, if the fault occurs near the generating station itself, then it may be as bad as or as good as whatever you tell, 95, sorry, 89 degrees or 88 degrees or 90 degree, right? So angle between voltage and current is quite high in case of fault. So this is the fault current. In this basic circuit, VR is equal to IR, Vx is equal to IXL, and then load, capacitance of the line. But when fault occurs, load and capacitor are gone. So total voltage V by Kirchhoff's law is just IR plus IXL, VR plus Vx. And if I draw the vector diagram for that, you see, the vector diagram would be like this: IR, IXL, and IZ. And as I told you, R is very small. Here it is exaggerated as such, but R would be very small. XL is very large, and therefore phi is to the tune of 75, 80, 85, or 90, 88, 89, or 90 degrees. Very large, right? So this is the vector diagram. Now going further, you see, if I remove, because after all what I was doing, IR, IXL and IZ. If I remove I, then it is RX and Z. So RXL and Z, this is known as impedance triangle of a line. So Z is the impedance of line. Which impedance? From relay to fault. O is the relay location and Z is the impedance up to fault. R is the resistance of that fault. XL is the reactance of that fault. R is very low. Therefore, the angle between R and Z is very high. To say in other words, you see, the angle between IR, that is I, and V is, because I is a reference vector, angle between I and V is very large. Other way telling, I can tell that impedance vector Z lies in first quadrant of the Rx plane. R is on x-axis and x is on y-axis. So I will not tell xy axis because otherwise there will be misunderstanding. X is not on x-axis. X is on axis. Reactance is on y-axis. So I will tell now Rx plane only. So in Rx plane you can show Z. But you see, it is not so that impedance lies in first quadrant. Impedance can lie in second, third, or fourth quadrant also. If I am talking about resistance and capacitive reactance, if there is a long line, and obviously it is a capacitance, and nowadays people connect the capacitance at the receiving and shunt capacitance to improve power factor, then in light load condition, R and XC, that Z will lie in fourth quadrant, right? So that is the fourth quadrant. And then if you talk further, right, then I've got this relay R, right, and generators on both sides. There are two lines. fault is at F. Now, how will relay look at that if it is not directional? If it is not directional, then F is behind R. Behind R means current is flowing in reverse direction. In that case, you can say that this Z is in third quadrant. Z is in third quadrant. That means fault behind the relay is in third quadrant. And you obviously do not want to see fault in third quadrant, right? Because for fault F, R should not operate. Because if R operates, its CB operates. And if its CB operates, fault is disconnected from bus B. That means the current which was flowing from generator A, that means from bus C to bus B, will also stop, which is wrong because there was no fault. Fault is in line AB. Therefore, it is very necessary that distance relay has to be directional. Therefore, we were talking in overcurrent relay directional and non-directional. Here we have not to talk like that. Distance relays have to be by default directional. They have to be by default directional. So in this case, you have to use some distance relay in conjunction with directional relay. That is very important, right? That is really very important. So the principle of distance relay can be understood like this also. I have got some relay R. CT is there, right? Line AB is there. I want to protect line AB. And the impedance of line ABK is known well before even erecting the line, because I knew what what is going to be the distance between R and Y wire, Y and B wire. I don't know that, so I can calculate X, I can calculate R, so I can calculate K. I know what is the set impedance K. So that set impedance K I have to set in the relay. How will I set? Across CT of the relay, across CT of the line, I will connect a replica impedance. Replica means impedance for 15 volt. It is not, voltage is not a question, and that is available in market. If say R is 5 ohms and X is 20 ohms, then R of 5 ohms and reactor of 20 ohm I will purchase from market and will connect them in series and connect them across CT. So across CT I have got the impedance, set impedance K. So whenever fault occurs, any fault occurs, that even though fault does not occur, then also current is passing. But when fault occurs, the current passes through K and the voltage drop Ki will be there. And I have got PT also. I am telling local PT and local CT. Local PT is there. Across local PT, voltage V. Rated voltage is 110 volt. But at the time of fault, the voltage will collapse. So some voltage less than 110 volt will be there, and that will be measured by V. So I have got two vectors, Ki vector and V vector. If Ki equal to V, it is a threshold condition. If Ki equal to V, it's a threshold condition. Ki equal to V, or another words, V is Iz. What is V? V means the voltage. Voltage up to fault point. Because Z is up to fault point. So V is equal to Iz. Ki is equal to Iz. If I remove I both sides, then Z is equal to K is the threshold condition. And if you want to draw the characteristics on Rx plane, now we will be doing on Rx plane. Overcurrent relay characteristic we were doing on IT plane. This we will be doing on Rx plane. Z is equal to K is a circle with O as origin, relay location as origin. Circle with radius K is the characteristic of an impedance relay. See, very important point. circle with correct radius k. That means it covers first quadrant, second quadrant, third quadrant, fourth quadrant, every quadrant. And I want to measure the impedance only in first quadrant. So this characteristic is from that angle not useful. But this is the basis of distance relay. Obviously, another way telling Z1, IZ1, that is current, fault current multiplied by Z1. What is Z1? Z1 is up to F1. So I Z1 will be obviously less than Ki. Will be obviously less than uh, Ki. Ki is the, sorry, F1 into Z1. So I into Z1, I1 into Z1 is obviously going to be less than K, right? Because K is my set impedance. So I Z1 is going to be less than Ki. It will not be, because K is larger, Z1 is smaller. Or other way around, Z1 is less than K. Z1 is less than K is operating condition. Other way of speaking, any point which lies within the circle is the operating region. And similarly speaking, Z2, that is fault outside, IZ2 is always less than, is always more than K, and IZ2 is more than Ki, or that way Z2 is more than K is out of circle, and any point out of circle that way is not within our characteristics. So relay should block. So relay operates if the, relay is threshold if the relay operating point is on the circle. Relay operates if the operating point lies within the circle, and relay blocks if the operating point goes outside the circle. This is what one has to one has to uh, one has to understand, right? And these things, if I want to show in characteristics, I can show like this: Ki equal to V. So K is lying on circle. So this is threshold condition. Ki is equal to V is a threshold condition. So if Ki equal to V, it is threshold. If Ki is less than V, relay operates. If Ki is more than V, relay blocks. So this is an amplitude comparator. Amplitude comparator means relay measures the amplitudes, magnitudes. It is known as amplitude comparator, right? So amplitude comparator impedance relay measures Ki and V, right? So that is how it happens. But the manufacturers very rarely prefer amplitude comparators. They prefer phase comparators. What is phase comparator? Because if you pass current through coil and fault current is large, then coil dimensions will be larger, relay will be costlier. Rather than that, in phase comparator, what I do, I measure angle between two vectors. If the angle between two vectors is 90 degree, it is threshold. If angle between two vectors is less than 90 degree, it is an operate condition. And if angle is more than 90 degree, then it is a block condition, right? So if I see further, this is the distance characteristic. Line to be protected, you can see it is at an angle 75 or 80 degree. As I told to you, line is highly reactive. K is the set impedance. K is the set impedance. Any point within the circle is operate area, outside is block area, and circle is a threshold area. Uh, the same thing can be seen like this. At the y-axis, it is the E, induced EMF. On y-axis, if I plot voltage, then it is induced EMF, right? And x-axis is distance. If I go further, fault occurs and fault occurs. If I go further, the voltage is going on decreasing, I times Z. So more Z, more collapse, more Z, more collapse, right? So when internal fault occurs, where is my relay? My relay is shown. See, relay location is shown. Location of the relay is being shown. Where the location of the relay is, relay is not near generator, it is on line. So it is somewhere on distance axis. So at that point, you see the voltage that is there, measured voltage, is Vm for the threshold condition, right? And if the outside fault is that another voltage Vz, Iz2, right? Iz1, Iz2 are, I mean, there are different conditions. That means for the operate value, what will be the condition? For the threshold, what will be the condition, right? So Z1, Z2 and K. Z1 is the I. What is Z1? Z1 is not equal to K. Z1 is less than K, you can see, because Z1 is less than threshold. So relay operates. Z2 is more than K, so relay blocks, right? Similarly, if you talk about threshold condition, and you can talk about external fault for uh, Iz2 will be is more than K, therefore relay blocks, right? So blocking and etc. can be shown by this ZS is the source impedance. But your relay is not affected by source impedance because it is not seeing ZS. It is measuring the voltage at the local point only, at the local bus, where the local means at the place where the relay is located. Right? So that can be explained like this also. So having talked about this, you see, these things, we have not talked about different types of characteristic. We have simply talked about uh, the principle of distance relay. What we have talked, we have started from here that if we want to understand distance relay, talk about a power system. This is a simple power system, right? Voltage, load, and R and XL. When fault occurs, load is shorted. So V is equal to VR plus Vx. From there, we have plotted an impedance triangle RxZ, right? And that RxZ, we have seen that Z measured by the relay is in first quadrant. I want to measure in first quadrant only, but it can be in second quadrant also if it's a capacitive load. And it can be in third quadrant also. I mean, sorry, it can be in fourth quadrant also if it's a capacitive load. And it can be in third quadrant also if the fault is behind the relay. What is meant by fault behind the relay? That also we talked, right? So this will be fault seen in third quadrant, and this we do not want to see. So with any relay, this will happen if it is non-directional. So it has to be directional. So what is directional? What is non-directional? Yes, this simple thing also can be made directional. That means we have to add directional relay to this. Means this impedance relay and directional relay. Two relays have to be used together. Then you can you can avoid seeing the fault behind the relay, right? Then we talked about this what the principle, yeah, right? That Z is equal to K is the characteristic, and that characteristic is like a circle with origin at O or origin as relay location. It will see in all four quadrants. So that is our problem, right? So that problem has to be solved. But basically, this is a distance relay and it is measuring distance. O, the origin is a relay location and transmission line to be protected and everything I have shown. So everything is completed, right? And this is characteristic wise, this is the amplitude comparator impedance relay. That is what we have seen. If K equal to V, threshold condition. Otherwise, if K is the set impedance, it cannot vary. But if V is less than Ki, right, that means voltage within the circle. Iz is less than Ki. Ki will remain same, but V will be within the circle. Then it is the operate uh, condition. And if V goes out of the circle, it is the block circle. Right? So that is also what we have seen. So this shows everything, line to be protected and everything. This also we talked about, right? Graphically, it can be represented like this. So having said so much, we will go further, because you see, slowly we will go further in distance protection. Distance protection is little difficult than overcurrent protection. Maybe principle is very easy, but when we will start with problems in distance measurement, it is going to be more and more difficult. There are about 16 to 17 problems in distance protection, right? And I mean, 7 problems means the conditions under which the distance relay will not measure the correct impedance. It will measure the incorrect impedance. Then to many of the problems, there are solutions. To some of the problems, the solutions are in the are with the research people. They are yet being researched. So distance relay is yet a topic where people can do research, right? So that way, distance protection is little complicated, and from overcurrent to distance, we have entered into first complication, right? So distance, as I told you, there are 16 problems, means so many limitations. So yet third kind of protection must be there. So we have to go to, so transmission line is protected by three kinds of protections. Three kinds of protections. We are seeing the second kind. So in this second kind, we would like to read a sentence, as so often we are reading the sentences. One Swami Anubhavanandji is there. Mostly is roaming around the world and giving his lectures. Very well known. Disciple of Swami Chinmayanandji and a very humorous speaker. Uh, he has given this sentence. Today is my happiest day. Tell any day. You tell tomorrow. Today is my happiest day. You tell after 15 days. Today is my happiest day. Every day should be happiest. You should remain happy every day. That is the meaning. But spoken very nicely. Today is my happiest day. And I love this sentence. I have heard him. Very humorous person. Very light person. You will not feel that he is sannyasin. Wears the dress of sannyasin. But by speech, he is not sannyasin. By speech, he is not sannyasin. Because he does not speak in a normal way. Uh, some in some of the sentences I must have written that he says nobody is happy. Now, very tricky sentence. Nobody is happy. If you are somebody, if you are manager of the company, uh, if you are general manager of the company, if you are CEO of the company, if you are father, if you are father-in-law, if you are son, if you are somebody, then you are not happy. If you are father, then you are not happy, because you have to worry for the education of your children. You have to worry for your house. You have to worry for the money, how money will come for your house. So if you are somebody, you are not happy. If you are nobody, I am nobody. मैं ना कुछ हूं. I'm very happy. So he is very humorous, very humorous. He says that, you see, a dog was passing through a very, very short bridge, and with the bone, the dog likes bone. So bone was in his mouth, but somehow the mouth opened and bone slipped, and he was on the short bridge. Niche, at the bottom there was river. So he thought that I must catch it. And then in the river he could see his reflection. And there was another dog, obviously, another bone. So he thought that one bone is there. Let me have a second bone. He jumped and then very obviously he died. So he says that what is the moral of the story? The moral of the story is don't be too greedy. Don't be too greedy. So following that he says another story that Savitri was very क्या बोलते हैं हम सती बोलते हैं उसको सती मीन्स the girl who loves her husband so much that she would do anything for her husband. Satyavan was her husband. Satyavan died. So she went after the soul of the Satyavan up to Yamraj. Yamraj had to allow her. She was Sati. So Yamraj had to allow her. And she brought back the soul of Satyavan. And she started living with Satyavan once again. Anupavananji says that the whole moral of the story is you can be protected from God. Yam is God. You can be protected from God. But you cannot be protected from wife. आपको कहीं से भी खींच के ले आएगी. यम से भी खींच के ले आई. You can, पत्नी से जरा डरते रहना. So, you see, that story of Satyavan Savitri is also made so humorous. So, a very humorous person. Some sentences will follow in the time to come. So, friends, stay tuned with Adapt Me. Adapt Me has taught you full transmission line by protection of transmission line by overcurrent and earth fault relay. It has taught you many experiments which you can do in the laboratory to learn transmission line protection easily and with the results, with the practical results. Now, Adapt Me has started teaching you the distance protection. So please, please remain with Adapt Me. It is yet to teach you many things. There are some, if I mistake not, some 13 to 14 tutorials for distance protection of some 30-45 minutes each, right? So that will 45 minutes if I count, then 12 into 45 means 9 hours of speech. If I write, then it would be more, but 9 hours of speech for distance protection. But with that, I will not be able to add mathematics. I will not be able to add analysis because analysis cannot be read. It is of no use to read out the analysis. Therefore, if you want to go to analysis, if you want to understand the arithmetic, mathematics, if you want the mathematical proof, right? And if you want to do practice on distance protection, if you want to answer questions, many questions will be asked. And if you want to know whether you can answer or not. And while you are answering, the AI network of ADAPME will be measuring your logical capacity, analytical capacity, mathematical capacity, general understanding capacity. Many things it will be measuring and it will let you know from the back end everything for you. You can know yourself. What you have understood out of the protection. But for that, my friends, module 4 will be uh, shortly out. 3 modules are available in the market. For that, you will have to pay. For that, you have to add up. I mean, you have to upload this Adapt Me from Play Store at no cost, no doubt. But once you upload these tuitions, these tutorials, you will have to pay for that. And and by paying, you will be able to learn. But this much is free of cost because this is on video. So please remain with this. And if you like this in YouTube video, at least press the like button. Not very time taking, no. Just press the like button. And also share is also there. Press the share button and send it to your friends. Right. Talk to your friends also that this is a good thing. Teaching many things, right? So, and if you have not subscribed up till now, the channel Adapt Me, please subscribe. So do these many things. When the knowledge is coming to you at no cost, pay at least so much. आपको देना तो कुछ नहीं है. No money is to be given. Only you have to press 3 buttons. One subscribe button, another share button, and third like button. Please do that much for Adapt Me. To pay in another terms, to pay, you do so much. Thank you, friends, and good day.